We are here to discuss about the cryptographic transposition, encryption and decryption. Transposition. It's a simple data encryption scheme in which plain text characteristics are shifted in regular patterns to form a ciphertext. Mathematically, these ciphers need to be bijective for the existence of inverse functions that can be used to decrypt. There are various type of transposition ciphers like rail fence cipher, root cipher, transposition cipher, double transposition cipher. Rail fence cipher. Rail fence cipher is generally used. It's explained like this. In rail fence cipher, the plain text is written downwards diagonally as successive rails. For an imaginary fence. Then moving up, and while we reach the bottom rail. While we reach the top rail, the message is written down again until the whole plain text is written out. The message is then read off in rows. We can see in this pattern. See the quick brown fox. This is the plain text, and it's encrypted as this pattern. So it is written as such, this pattern. So it will written be another form is root cipher. Root cipher. It's a transposition cipher where key is which route to follow, reading the cipher text from the block created in the plain text. The plain text is written in grid and then read off in route chosen. See, the example of this is the quick brown fox jump. This is the original text, and the format in which it follows is in this. It's a way. Another form is transposition cipher. The message is written out in rows of form of fixed length and then read out again column by column. The columns are chosen in same scramble order. Both the width of the rows and the permutations of the columns are usually defined by a keyword. The keyword is the important factor here because the keyword defines how to decrypt the code. See, this is the code we got. A message from Mary Stewart, kill the queen. If this is decrypted, and it will be decrypted as this pattern. Uh, Coming to double transposition cipher, single columnar transposition could be attacked by guessing possible column lengths, rating the message length out of its columns, and then looking for possible anagrams. Thus, to make it stronger and most difficult to decrypt, we use double transposition cipher. Thus, to make the double transition is often used. This is a simply a columnar transposition applied twice. The same key can be used for both transpositions or two different keys. So, here also the key matters once again. So let's say attack, this is the original text, this will be decrypted twice. For once attack, this will be decrypted, and again it will be permutated into row this pattern. So we should know how to decrypt twice. In this assignment we will look at into the transposition ciphering with a key. This key adds another complexity for decryption. So the person receiving the encrypted message need to know the key to decrypt the message. So we basically take this breakdown into several steps. Step 1: take the input message and note its length. Note down its key and the length of the original message. The length of the key is equal to number of columns. The number of rows depend on the length of the messages and the key and additional spaces filled by the blank and space null characters. Step 5: the location of the character in the key with the lowest ASCII value is noted, and that column elements from the top to bottom are message or first elements are our encrypted message. Then the same is done by using the location of the next lowest ASCII value character and so on. So by this way we get our encrypted message. Example is C. Let's the enter text hello, and this is the key, and how are you is the plain text. So hello contains 5 characters 6. So this control HOW space A. This includes 5 characters. So this is the key length. So the message encrypted message will look some sort of like this. This is about decryption. Decryption is we assume that for decryption we obviously got the encrypted message. So we take down the length of it, and we know by for decryption we need to know the key, and we know the length of the key. So the step 3 is the number of rows required of the message length or key length. Note down the key location with the lowest ASCII value, and this location is the first column to be filled. The lowest ASCII value character collocation is the next column to be filled, and so on. The matrix formed in this decryption matrix. The matrix is read row-wise to form a decrypted message. See, this was the original text which we encrypted before, and as we know the key as hello, which we already know because we know we are the one who are decrypting it. So this is the one. So if we decode it, we will get the message as this. When we look at the code, the encryption part which is I'll explain right now.
Even offense. Last question.
uh, we the output path is stored, and this is a string copy. We'll copy it in this, and we concatenate string in the output.txt file. This str string length. This is used to know the length of the key. So we copy the encrypted message, and so we get the length of the string encrypted message by int represents integer. String length is the to know the length of the encrypted message. If the process division for if the encrypted message is is a is not an integral multiple of the key, then we get a loop. So we use the loop to append an extra characteristic, like probably a space. The I loop this is used to call the arrange key the of ascending order, because we use ascending order for the lowest ASCII value. The function f.h in the header file, that is the key characteristics numbering ascending order in the order of the file. We write the final string in the output file, and this is the as already we stored earlier. So this defines that. Well, coming to netsim. Here, however, is the in a plain text. HCL is the key text. When we run the code, we get the output as ORH AWE. So the format which it takes is the lowest ASCII value is E, H, and L. So this is arranged. This is kind of double encryption format. So this requires double encryption. So the cipher text is, as we observed, is ORH AWE. Coming to decryption, this is the original decrypted text, and this is the key. If we run it now, HCL. As we know, this is the converted key text. And HCL, this is the converted text. So it comes back to how are again once again. This is as we do it in the sample process. Now I will explain code. Now I will explain about the decryption format, decryption text. Decryption. Same. This is as in the encryption format. This is to know the size of the character. strlen. This is string length. This is string length command. This is used to know the string length of the string. Length of the string. This we need to check the length of the string is same as the length of the texted string. We first arrange the key in the ascending order. This defines the function.h in the header file, which we already used in earlier. So we put the string in the output file. If we come to user, we can observe it asks about the executable or jar file. How to get these files? Go to this. Flat this. We need to go to the my documents, and then to Visual Studio, and then projects, network 1, debug, network 1. This is an encrypted format. This is one for encryption. By this we can observe the code which we simulated and the code which is already used in the sample are same. And for decryption we use decryption. So we need to get this jar file earlier. This is already the encrypted code. This is the key which is converted in as per ASCII values. See, as we note, how are this is the same plain text which we already used earlier. I would like to also mention about the generation of exe file. We can get this from Visual Studio. This is a Visual Studio Express file. New project. We need to put a new name for it. We need to next. We need to. It's an empty project, so we create an add a source file. We need to add the header file. CP. We must definitely mention .c. Here we should run the code because which we learned earlier. To show the success of my code, we'll go to already executed file earlier. This is a Visual Studio file which we already created. Epsilon is for building the format. As we observe, it's succeeded. Thank you.